So these sessions aim to happen to anyone who wishes to learn about R. So you could be a student, you could be a program manager, you can be a statistician, or you can be an epidemiologist, or you're just a computer scientist, but interested in health research. And you want to learn a new tool to support you in your day-to-day work. And we will be doing these sessions at the same time every other week, so twice in a month. And we will be recording these sessions so that anybody who doesn't get a chance to attend, then they can review the recording. We'll be posting these videos on YouTube so that we can also expand the reach of the R language to other people. For today, for these sessions, we have amazing volunteer and support from Ashna. Ashna is a PhD student at the University of Oxford. She's an epidemiologist, and she has worked with different programs to support data science. And I've had the pleasure of working with Ashna for quite a bit now, and it's been amazing. So I will hand this over to Ashna. Ashna, please, you can start also by telling us why should we really think about using R, and then you can tell us more about what you're prepared for today.
Sounds good. Thank you. I feel like I should give you like a hype intro as well. Frank is like an R genius, so we're very lucky to have him here too. In terms of kind of the motivation behind learning R and why people even use it, it's a very, very powerful statistical software. But the cool thing is it doesn't just do statistics. I mean, everyone here saw all those graphs and through COVID of cases, of deaths, of hospitalizations. So R is also very, very powerful for producing things like that, for doing data visualizations. But also, I'm sure people have also tried to interact with data visualizations. R can also produce things like dashboards where you're interacting with the data. Basically, the motivation behind it is really to work with data or making data a lot easier to understand and easier to work with. So you can think of other things that also do this. In a way, Excel is a simpler version of this. Excel also helps you visualize data. Some folks might have used SPSS data, Python. There's a lot of different computer languages and programs you can use for data. R happens to be free, and because it's free, it makes it a lot more accessible. And because it's free, there's also a lot of help material out there. There's lots of people like us who have taken time to learn it, and people have posted kind of information and guidelines and such online. So it's a very accessible tool that way. So that's why we wanted to focus on R and teach you how to use R. And hopefully encourage people to use it in their own work, because its applications are kind of endless. Like Frank is a great example. He created a really cool COVID-19 dashboard using R where you could actually interact with the data visualizations. And if you come to one of our intermediate sessions on data visualization, he'll be showing like how those work and such. So it's good motivation to learn a program like this. But should anyone have any doubts throughout, feel free to ask, why are we doing this in the first place? What does this mean? What are the applications of this? As Frank said, this is a super informal group. So we encourage doubts and questions and such. So I'll pause there and see if anyone has any questions. Or if you want to add anything, Frank, feel free.
No, that sounds fantastic. So maybe just quickly, because our group is still very new, we are learning and we're trying some new applications of making ourselves more engaged. So if you go to the afredac.net and you select on the discussion, we plan to use this discussion board to have like an interactive session. So if you have any question, you can also just write it down. You just click on the reply and put your question. Like I just clicked on the reply, and I plan to ask a question later. So I just did that and I posted, and it just popped down on the discussion. So if you want to tell us where you think you would apply R in your work, you can just write in the discussion session and we can see how that works, whether it's useful or not. So dive into it, and then back to you, Ashna.
Thank you. I didn't even know you could do discussions like that. Afredac is really cool. Okay. I will share my screen then, and we will jump in. There we go. Oh yeah, I've responded everywhere, right? To generate some hype. So for those of you who were here last time, we're going through the same slide deck as we did last time. We kind of stopped around here. For those of you who weren't here last time, we encourage watching the previous video, or if you look in the documents pane on the Afredac RFC page, we've uploaded this, so you can feel free to follow along. We'll start off with some demonstrations in RStudio itself. So for those who have downloaded R and RStudio, we really encourage people to follow along on their computers. If you're super new, you haven't downloaded it, you prefer watching, that's cool. You can also watch and try to follow along that way. So I will go ahead and open RStudio. So notice I'm opening RStudio, not R. Because if I just open R, actually, I'll show you what it looks like if I just open R. Where are we? There's R. I made mine yellow. Yours is probably not yellow, but you can change the color here if you want. It can be, you can customize it as needed. But you can see when I open up R, it looks exactly like the console here. So R is just this part. And again, you can use the console like a calculator if you want. It's not very useful on its own. RStudio is the useful bit. So R is like the engine, and then RStudio is like your little notebook. You can actually write and do cooler things. So we encourage opening RStudio instead. But I'll go ahead and don't want to save that. So this is what it'll look like when you open up RStudio. I'm going to go ahead and open up a new script. So it's the first option here, our script. And if you remember from last time, we talked about kind of the 4 different sections of RStudio. So then there's the R script I just opened. This is the source pane over here, which just means that's where my document lives. So I'll use this. I can use this as like a Word document. This is where all the action will happen. There's the console pane, which is down here. Can people see my mouse, by the way, or am I just like hovering? Okay, cool. So the console is down here. This is, as I said, that's the engine. So anything I type up here, it'll be executed down here. So all the calculations and stuff happen because of this console. Up here is your environment. So if I create objects, which objects is something we'll get to at the end of the session if we have time, they'll appear here. And then this on the bottom right is the everything else pane. So you can see I have a file folder, which opens up kind of like your file explorer on your laptop. You have plots. So if I make any graphs, it'll come here. Packages, so a list of all the packages I have available, a helpful help thing, and then some other tabs over here. So we'll just quickly use the source pane here to create a little example script. And notice that anything that comes after this little number sign or hashtag, this is a comment. So this isn't actual code. I can run it still. So I run it. I usually press Control Enter to run, or you can, there's a nice, hold on. There's a helpful little like run button up here. You can run instead. But if you press Control Enter, nothing's happening, right? It's a comment. So it's not anything new. I can write some code here. For example, if I say 2 + 3, and again, I run, you can see it's written up here, but it's running down here. I can create an object. Suppose I create something called X. And I have named it here. If I run this, it'll create an object called X that holds the value test. I I can also use, towards the end of last session, we talked a little bit about basic functions in R. So if you've used Excel before, you know this, you can take like the sum of things, you can average things, you can perform various operations in it, and you can do the same thing in R as well. So suppose if I want to take the mean of 1, 2, 3. There we go. Oh, hold on. I've made a crucial error here. This will also make sense later today. We're going to talk about what the C means. But over here, it has taken the mean or the average of these 3 numbers here, because mean is a function that exists in R. Similarly, if I wanted to do, instead of taking the mean, I want to do a sum, I can add them up. So you can see R has, these are very simple functions, but we just want to use it to illustrate that there are things built into R. There are more complex functions. Last time we talked about functions that require things called arguments. So argument just means it's an input to the function over here. So as we kind of advance through these sessions, you'll get more and more complex functions. And should you ever be curious about what a function does, that's where this help pane is very, very helpful. So I can even search in here, mean over here. And it'll say mean. Base just means it's built into R. And it'll tell you what the function does. It takes the arithmetic mean. It tells you how to use it. And it gives you an example as well, usually. See examples. You can even run examples over here, which is very, very useful sometimes. So it gives you that and it'll run it for you to show you how it works. So we do encourage using the help pane over here. Let me pull you guys back up. There you are. So we do encourage using the help pane over here. If you ever want to know what a function does, you can also go question mark. So if I can write this up here or directly in the console, by the question mark mean, it'll pull up the help page over here. So it's just a good way to find out what something does if you're not sure. Another thing we encourage, and I'll just take a moment, I'll pause for a moment just to talk about it, is Googling. So if somebody tells you that they're good at coding, they're probably just really, really good at Googling how to code. So we truly encourage Googling things. If you are unsure what something does, chances are, because as we said, R is a free software and there's lots of help available out there. So chances are somebody else has had the exact same problem as you. So we really encourage Googling. And actually, if you're curious, so within the PowerPoint, just on this will take a few minutes, so we won't spend time on it now, but we encourage you, we can maybe even post this in the discussion later, encourage you how to Google these things. And each of these things is possible in R. So we encourage people to Google and try to find a help page or an example of somebody who has done this exact thing using R. And then you can try to recreate their example if you want, but we really just want to encourage people how to Google effectively to find help. So that is that. We'll kind of move on to the next little bit here. So this are document types we're going to talk about. So what we just looked at a few seconds ago was an R script, and you saw in kind of when I was opening up a new document, I clicked in new R script. So R scripts are the most basic types of files in R. There are many, many other types of documents you can create, and each of them, there's different reasons why you'd create different ones. Standalone scripts and other documents are pretty rare. So normally if you're doing something like, for example, creating a dashboard or creating a report, it's pretty rare that you'll just have one script. It's quite common that you'll have several scripts doing different things, several data sets that you're working with, and many different figures or different outputs that come from your scripts. So R actually has a handy way of making sure all of these are saved in the same place and are easily accessible. So we want to introduce you to the notion of R projects. So an R project enables your work to be bundled in a self-contained folder. R project is really just a fancy word for a folder on your computer. And within that folder, all the relevant scripts, data, figures, outputs, and histories are stored in there. So it's just a really good way to organize organize yourself. As beginners, we'll stick with creating standalone scripts and stuff, but it's worth it just to show you what the idea of an R project is, because if you do continue in your R journey, chances are you will kind of end up in a place where you'll use R projects. And the idea behind an R project is to kind of standardize something called a working directory. So the working directory is it's a term you hear pretty often if you're using R. It's essentially the project's root folder, and we'll give you an example to illustrate what we mean. So a working directory is a file folder where R finds things relevant to your work. To figure out where your working directory is, for those of you who are following along, we encourage typing get WD into your console, just with open brackets like that, nothing inside the brackets. And you can, here I can show you actually, if I say get WD. So my working directory is at the root folder, which has my name. Yours will look different from mine. It might be at the root folder, it might be your desktop, it might be your downloads folder. It looks different for different people. And don't be worried if yours looks different. You can actually change where your working directory is. So basically, if I try to import a data set into R, if I try to work with anything, my R is going to be looking here. But suppose I want it to look somewhere else, I can actually change my working directory. But it is bad practice to manually tell R where your working directory is. So in the next session, we'll talk about a very handy package that kind of automatically routes your R scripts and changes your working directory as needed to where your data lives. But just hold on to that thought for now, and we'll come back to it. But in the meantime, another good way of kind of setting your working directory where you want it to is to create an R project. Actually, maybe I'll close RStudio altogether and reopen it just to reset everything. And I'll say I will be a bad person and ignore the update. So over here, I can either open, actually no. So you'll see over here, our project. I don't think it's one of the different document types you can do, because an R project is essentially a folder, so it can contain many different document types. So instead of going over here, I'm going to go up to the file. Instead of saying new file, I'll say new project. And for those who are following, I encourage you to follow along if you can. And you can see it's something's happening up here, right? It's creating a new project. So now another window will pop up. Here, there's several different options. You can stick to the new directory over here. So basically now you're getting the idea of what a working directory is. So here it'll start a project in a brand new working directory, and it'll kind of change the working directory to where this project is. So I'll say new directory. Again, I'm going to say new project. You guys are already seeing there's so many cool things you can do with R. New project. So I'm going to call this my first project. You can call it anything you want. By default, mine saves on my desktop, but if you click browse, you can kind of save it where you'd like to save it. I'm okay with mine being on my desktop. Don't worry about any of these two. You don't need to click those. And then I'll just say create project. And you can see, oh, again, it'll ask me, I'm going to ignore again. Over here now you can see it looks the same as RStudio looks normally, but the key difference here is in the top right. You'll see I'm now within something called my first project. And again, I said it's just a folder, right? It really is just a folder. If I close this, I'm going to close R now. I minimize this. Oh, sorry, guys, it's my sister in the background. So if you can see, my first project is now a folder on my desktop. And over here, if I double click this, my first R project, now we're back in here. And once again, we'll ignore the update. So over here, now you can see in the files pane on the right side, the only file that exists is a .rproj file. So over here, the .rproj file isn't really anything in itself. It just, if you double click it, your R project opens. I can create various scripts and save it. Project script 1. I won't put anything in it. I'll just press Control S. And then I'll save it to my first project. If I save it, now you can see all my scripts kind of live here. I can create as many projects, script 2, Control S. I can create as many scripts as I want, really, but just to show you, and they'll all kind of end up living here. And again, if I close, suppose I close RStudio here, and if I click the R project file again, it should automatically open up my R project, and all my scripts kind of live here. So I can open up the scripts as needed. And you'll see they'll open up with different tabs over here. So again, our projects are really just useful for organization. Yeah, anything I produce, if suppose I create a graph or I create a figure from here, it'll be saved in this project. So it's really just good for organization for when you get to the stage where you have multiple scripts or are working with multiple data sets. But we just wanted to kind of mention it offhand so everyone knows what our project means. How are we doing on time? I think we're actually doing really okay on time. Oh, great. Are there any questions? Questions, comments, concerns, all are welcome.
I think I just wanted to add on creating the R project for Windows PC. So because Windows PC does not give you the file function on top of your R.
Oh, okay.
Yes. So the other quick way of opening a new R project, actually, if you can open your R, and then if we go to the R project on your right, and then you click on the drop down, then you can use that as a way to. It does the same thing. It's the same process, and then you can just create and name your new project.
That is smart. Okay, that is good to know. Oh yeah, there's also, oh yeah, I guess there's also a new project up here, create a project. Oh, there's so many different ways to do it. Okay.
Oh yeah.
So cool. Very nice. Okay.
Yeah.
That is good to know. Oh, and while we're here, maybe we'll mention for folks who are curious about this like massive drop-down list of different documents. Kind of the ones that are more, in theory, you can make any of these. The ones that are more common are, so most common is R script, but also R Markdown is super common, and that's something we'll cover several sessions from now, or potentially one of the intermediate sessions. R Markdown, just to note, is very, very useful for automated reporting. And what I mean by that is, like, for those of you who work in healthcare settings, you might be used to seeing, like, at the end of the month or at the end of like a certain period, there are updates of like, this is how many beds are used. These are infection rates going on at the hospital. We have X number of staff shortages. So it's a report that every month or however often it's produced, it's just the numbers and the graphs that are being updated in that. So R Markdown is very, very handy for creating things like that. You can create, and you kind of automate it. So basically it'll be attached to like a living data set, and it'll automatically update the report however you want to update, however often you want to update it. And you can create things like Word documents, PowerPoint presentations. It's very handy for any form of regular reporting. But that's just it's a quick plug for R Markdown. So for those of you who are interested, you can stick along, and we'll eventually get to talking about that as well.
I have a question.
Oh, yes, question.
If you had a data set, can you save it in the same R project here? Or
Yeah, you can. So if you have like an Excel, suppose, I think I have somewhere, there's like an example data set. Yes. So if I have like a data set over here, I can save it in my R project over here. And now basically all you can see, it's already, my R has recognized it's in there. So because it's in my R project, makes it very easy to work with. I can just directly export. I can view file, import data set. It's makes it very easy to work with, basically. But yeah, our projects are very, very handy that way. that is our project. Next, we can talk about objects. Basically, everything in R is an object. For those who are familiar with other computer programs, R is something called an object-oriented language. Basically, everything you store in R, whether it's a data set, a variable, even things like graphs and figures, anything that's assigned a name or a label is an object and can be referenced later in commands. So an object basically exists or comes into existence when you assign it a value. And when it's assigned a value, it appears in that environment pane. And then the advantage of creating an object and storing it there is that now I can use it or perform different operations on it, change it, redefine it. And yeah, so that way you don't have to kind of create it every time. Now I've saved it as something and I can refer to it by its name now. So for example, the way you create an object is you just have this little arrow sign operator. People who are familiar with other languages like Python, you use an equal sign, which I mean, equals is more intuitive, but this combination is supposed to be like an arrow, like I'm assigning it. That being said, an equal sign will work in R. It's just not good practice because there's very specific scenarios where it actually messes up the value of an object. So we encourage people to use this little arrow sign. But that being said, if you accidentally use an equal sign, it'll still, given that you aren't doing this, I'm not even sure what the very specific situation is, but it's pretty rare. But given that you aren't doing that, it'll still kind of work as expected. So over here in this example, we're creating an object which we've named current_week, and we're giving it the value of 2018 week 10. And then basically now that I've created an object, I can refer to it if I just say current week. That command will print out that value, and we can show you exactly how that works. Oh, you know what? Maybe I'll work in my R project. Creating objects. So I have current week. Oh, 2018 week 10. So if I run that, now you can see in my environment pane, there's something called current week, and I've given it the value 2018 week 10. If I print out, if I just press this now, I can print it out, which is very exciting. And this is particularly handy when you want to do more things with it. Normally you don't just print out an object, but you kind of use it in other operations and data sets and figures, that sort of thing. But that's a really simple way of creating an object. An important thing to mention is object names. The reason we use an underscore here is that you cannot have, I can't say current week like this, because an error will happen. So unexpected symbol in current week. So basically R does not like blank spaces, and it won't really understand what to do with this. So that's why you have to current week underscore. Some people do dots to represent spaces. Similarly, you can't do like this will also throw an error if you do a little dash. I will say object current not found because it thinks a dash to R, a dash is a minus sign. So it'll think you're taking something called current and saying current minus week, and it'll be like, I don't know what that is. So then it freaks out. So we recommend if you have multiple words in your object, or you can, I could just call this week and then my life is easy. But then if you have multiple words, separate it with an underscore or a dot. Because otherwise your computer will not like that. We'll go back here. So basically what we created here was a very simple object. It's got one name and it holds one thing. But in R, you can have more complicated objects. We thought this visualization was super cool because it actually illustrates different object structures. Some of these are far more common than the others. The two most common object structures we come across are called vectors, which are one-dimensional, and then data frames, which are two-dimensional. You can have different things like a matrix, which looks like a data frame, but we'll kind of get to the difference between these two in a moment. You have an array, which is actually a three-dimensional data structure, which, I personally have never used, but you do use it in more complex situations. And then you have these things called lists, which contain many different object structures, for example, but these ones are less common, more complicated. So we'll focus kind of on vectors and data frames. Vectors, as we said, are one-dimensional. It's just column with data in it. Here's an example of, here we're creating an object called age. Again, we're using this little arrow sign to create it. And remember at the beginning of the session, I added the C and I was like, we're going to talk about it later. So this is where the C comes in. So C is just short for, I think, combine. So it combines and anything in the brackets after that. So C itself is a function. And basically combines anything in those brackets into like a little row like this. So over here, I've combined 4 ages into a little row, and like it's stored those 4 ages in that row. And similarly here, data frame does the same thing, but now it can have, oh, we have a chat. Now you can have, combine or concatenate is what C stands for. So over here, a data frame will do the same thing, but now you can have multiple kind of columns of data. So over here in this example, the function is just called data.frame. And we're saying one column of it should be age, which is the exact same thing as above. And then one column of it is sex over here. And here actually is a good place to pause and show you exactly the what's it called? The advantage of creating objects. So I'm going to go ahead. I'm going to do the exact same thing. I'm going to create an object called age. And we're going to say, I'm just putting random ages here. So here you can see it's stored as age. It'll even tell me what type of object it is, which we'll get to in the next slide. Oh, am I frozen? Oh no, hold on.
No, you're doing great. You have not frozen.
I'm
Yeah.
frozen. Okay. So,
Okay. Oh no, it might be frozen.
Your internet today is exceptional.
Oh, I love it. I know last week the internet was just, it was not doing its thing. Okay, so we have age, and it even tells you up here that it's storing 4 numbers. It'll say numbers 1 to 4. It's stored 2, 13, 6, and 39, which is exactly what I typed here. Now the advantage of this is, suppose now I want to create a data frame where I have one column called sex. F, M, F. And now I have one column called age, and I don't have to actually specify because now age is already stored as 4 numbers. So now my data frame looks like this. So that was the advantage of storing age as an object, is I could just refer to it by name. And R knows that there are 4 numbers stored in there. So now my data frame has a column called sex and a column called age. And I can even store my data frame. I'll just call it data set 1. And you can see now in my environment pane, it's stored. The R does store data different, like in a separate place from values. So anything that is one-dimensional, so it's just a single number, or it's a vector, so a sort of string of numbers, it'll store under something called values. And then data, anything that's 2-dimensional or beyond, it'll store up here. And you can even, if you can see my mouse kind of changes when I hover over it, I can even click on it and open it up in its own little window as a data set. That's super handy. I'm going to save that. So
I have a question.
Oh, yes.
So from what you just showed us, is you created an age sort of object, and you added the numbers, which you put in brackets, and bound them by a combine function, let's see. And then you went ahead to prepare a data set where it became a data frame, you put a sex, and then the object that you created before, age, you brought it into this data set. So does it mean someone can create a data set straight on R?
Yeah, You can
Wow.
create, you can create a, that's a good question. Yeah, you can, so here I'm creating my own data set. I'm over here in following sessions, or actually, no, I think we did this previous session. We showed how to import data sets. So suppose it exists in Excel or something else, and you can, then technically your data set is separate and you're bringing it into R. But yeah, exactly. This is how you can create a data set within R as well. You can use that for visualization, summaries, whatever you'd like. But yeah.
That's very useful. And the other thing that I wanted just to add, you can see when you're creating a data frame, you kind of need to have equal number of those
rows.
rows. So that's what in age we had 1, 2, 3, 4 rows. That's why in sex also we kind of have 4. If we just had 3, I think it would give us an error.
Yeah, there we go. It says it even tells you what error, which is really good.
It is, we cannot add this because you have 3 and 4. Doesn't make our mind.
Exactly. Exactly.
Yeah.
Yeah, that's a good point. It has to be the exact same length in order for R to be able to squish it together into a data set. But also like for aesthetic reasons, like you can, this is something that I like stupidly did not know until very recently, so maybe it's worth mentioning. For aesthetic reasons, I put extra spaces in places. So like I have a little extra space after my number sign for comments. This is the exact same thing. It won't change anything. And same thing for vectors. I like to put spaces in between. You might not like to, but all of this will work the exact same. Similarly, if I'm creating a data frame that has lots of columns for aesthetic reasons, I like to separate kind of age. And then if I want like a third column called height, like that'll be kind of on its own. Oh my goodness, is this like a 13-year-old who's okay? Well, we're gonna make a really, really tall 6-year-old. But for aesthetic purposes, I like to kind of have each thing on its own row. You don't have to do that. This will, if I get rid of the spacing here, it'll work the exact same way. So that's a total you situation. However you'd like to code is up to you. But yeah, worth mentioning. Also worth mentioning, if people ever have trouble with a light background, you can change how your RStudio looks. If I remember how to do that. I think somewhere in tools, right? File. Actually, yeah.
It's somewhere in tool. Where is the tools?
Yeah.
Oh, you have it on actually in the middle. Let's go to your right. Further right, like you're going all the way.
Oh, I have it here.
There you
there
have
we go.
it.
It's because I have a new laptop with like a little there's a dent over here. Anyways, here if I go global options,
yeah,
appearance. Now I can actually change. So right now my theme is called Chrome, but you can kind of change it to look. There's a few themes that the background is dark for people who prefer that. I like the Dracula theme. It makes me feel like a hacker. But there's lots of options here. But for ease of sort of visualization, I'll keep with Chrome, and you can change the font size as well, and the font, the sort of the text as well. So that is totally up to you. You can change how you code. We'll go back here. We just talked about object structures. There's also different object classes. So this just means different, basically, types of objects. Here's a table that lists a whole bunch of different classes. You won't end up using all of these, but it's worth it showing you all of them. Some of the more common ones are up here. So there's a character. So characters are texts, words, sentences, anything within quotation marks is a character. And this is an example over here. Both integers and numerics. These are both numbers. The only difference is that integers are whole numbers, so there's no decimals. Numeric can include decimals, but they're both treated as numbers. Factors are, they're non-numeric, so they're not numbers typically. They're categories, but they have an inherent order. So a good example of a factor could be if you have BMI, and you have an inherent order of underweight, normal, overweight, that sort of thing. So these are technically they're categories, but there's an inherent order to them. Whereas characters can also be categories, but there's no order. They're just this random text. There's also dates. Dates R actually treats dates like numbers, but they're like special types of numbers. For example, so R will recognize all of these 3 different examples as dates. But because it's classified as a date specifically as that type of object class, you can actually add days or add months to it. You can perform different operations with it. So it's kind of ends up being its own thing as well. The rest of these are not as common, but you'll see. You might be wondering why on earth is a data frame over here. Weirdly, a data frame is both an object structure and an object class. You don't have to worry about that differentiation really. Just to say that data frames itself, that's where they differ from matrices, because data frames are also a type, an object class. There are different operations you can perform to data frames, which we'll see in more advanced sessions. You can manipulate them, you can add or subtract columns, that sort of thing. So it ends up being its own object class as well. Now it's a question for you. I think Frank will post this, or actually no, we'll leave it over here, but feel free to either unmute. Oh, Rennie is saying, is there a place where I can access the meaning or definition of each symbol on R? That is, ooh, I revealed the answer. That is a good question. By symbol, do you mean like different classes or different symbol as in like the different operations? Like plus, minus, that sort of thing, $sign. We can actually see how to do it here. Different operations in R operators. So this might be what you're referring to. If this is it, these are the different operators in R in terms of addition, subtraction, multiplication, division, exponent, modulus, and these 2 are not used as often. But I think this example shows you what each of them means. But then there's also, yes, that's right.
And I think also to add, maybe Renik is referring to, for a beginner, to just start knowing, like, where do I put quotation marks? When do I not put quotation marks? When do I put a comma, and when don't I put a comma? So those are the things that sort of start slowly, and you kind of keep building on it. So for operations, maybe we can post this link on the chat, as well as we can just add it to the discussion.
Yeah, it's a good point.
Yeah.
For the like knowing where to put a comma and stuff and quotations, a lot of it, as Frank said, is just like it's trial and error. So you can see what happens. I put quotation marks here to create something called current week, but suppose I hadn't, you can see what would happen. It would give me an error over here because it would say object W10 is not found. So if I don't have quotations around something, R thinks it's an object that exists somewhere, and it'll attempt to look for it. But because it doesn't exist, it'll throw an error to say it's not found. 2018 R recognizes as a number, so I don't need quotations around it. And then this little dash R recognizes as a minus sign. So it's kind of looking for 2018 minus what? And the what it can't find because it can't find something called W10. That's why you kind of have to put quotations around it for R to recognize that, like, no, this is a character on its own. And in terms of commas as well, commas usually separate things. So if I want to have like multiple entries in my vector, I'll separate them with a comma. Similarly, there's some additional commas here in this data frame, right? So if I have, so here the commas are creating a vector called sex, but then another comma separates that from a column called age. Another comma separates that from a column called height. But again, a lot of these are just, it's a trial and error thing. So you can see what happens if I don't have a comma here. If I delete these, what'll happen? And it'll give me an error. And usually R's errors are pretty informative, which is helpful. It'll say unexpected symbol, as in it's a space. R gets very confused with some spaces like this, but as soon as I put a comma there, this red dot should disappear. There we go. But to learn what different operations do, in terms of these operators here, greater than, less than, that sort of thing, that's just very handy to test them out and see what happens. And I think this example here, we'll definitely post that in the discussion as well. It kind of does a good job of showing you how those operations are applied, different things. In terms of quotations, I saw Duncan's question. I don't think in practice there is any difference with the single and double quotations, but it's worth a try. You can kind of use whatever your default is. Hold on. Let's see. Yeah, no, you can use either one. And similarly here, let's just try to make sure it's, yep, both are good. So you can use a single or double quotation, whichever is kind of default, I guess. But you'll see R usually stores it anyways. Even if you use a single quotation, it'll kind of store it as a, if I print out current week, it'll print out with the double quotation. So then the double quotation is a default for R, but still understands the single kind of quotation marks. So over here, we can use the last few minutes maybe for this question. Feel free to, for those of you who saw the answer, that's okay, that was my mistake. Feel free to post in the chat what class and or structure you think these three are. So class meaning number, character, date, factor, structure meaning vector, data frame, that sort of thing. So you can either unmute yourself if you'd like, or post in the chat, whatever you're comfortable with. But I'll give a couple minutes for people to do that. Oh, nice. Yeah, another like I see Duncan has posted string. String and character are often used interchangeably. I know in some other programming languages they just use string, but usually string and character mean the same thing.
This is my country here.
Nice. Duncan's beating everybody. Oh wait, Duncan, I encourage you to look. So you've named the three structures. What about the classes? Or you could the class as in like character, numeric, factor, date.
Oh, okay.
Nice. Yeah, number 2 is integer.
Okay.
And then, oh, do you want to take a stab at number 3?
Integer.
Integer, yeah.
Logical.
Logical.
Factor?
Date.
Date, sorry.
Yeah. Yeah, so the third one is integer, logical, and date, and it's a data frame of, that's another differentiation between data frame and matrix. A matrix can only hold class, like a single type of class. So it can only hold numbers or can only hold characters, but data frames can hold columns of different classes, which is what's shown here. But I think that could actually be a good place to pause. We've covered quite a bit in this session, so I'll just take a moment to ask if there's any more questions.
So there is just one thing I wanted to add, Ashna.
Yeah.
If you leave your slide, the question whether there's a difference between using single and double quotation marks. So I think you can use any of those interchangeably. However, if you start with double quotation marks, please finish the number with the similar double quotation mark. If you use single quotation mark, finish it with single quotation mark. If you change like what Ashna just did, you start with double, and then like before the F, there's double, and at the end of the F, there's single. Says, no, I don't like that.
It does not like it. It thinks I'm continuing the operation.
Yeah, it's actually telling you a lot of gibberish there.
But yeah, it doesn't like it. There you go. Now we're stuck in an endless loop. It keeps asking me for a plus. It's okay, I'll try to exit from the R session, then it'll figure itself out. That's a good point.
It's usually sometimes a loop, so you just have to escape twice before.
There we go.
Yeah.
But yeah, definitely it does not like the inconsistency in quotations.
No.
Yeah, that's a really good point, actually. Are there any other questions or closing comment? Otherwise, I think that's yeah, for those who haven't downloaded R or RStudio yet, we encourage you to do so you can kind of test out some of the examples we did today. You can try creating your own R project. You can try opening up your own R project script, doing different operations, testing out different operators to figure out what does what. The best way to learn R is just to like type away and see things. And again, for folks who are curious, we encourage you to try Googling some of these and seeing what you find, if you can actually find some useful examples or help pages. And yes, you can use R to compose a song, which is very exciting. So it'll also give you some cool motivation, hopefully, to show you all the different things that R is able to do. But yeah, I think that's all from my end.
That's really nice, Ashna. Lots of claps to you. I would really encourage all of you to have your R session open, and you try to, to type just like what Ashna is doing. And this is the easiest way to learn coding. You just have to start writing it in the very wrong way. And before you know, you start getting the rhythm of it.
Exactly. I think you said it totally correctly on the Afredac page. We are lazy coders. We learn the hard way, but that's probably the best way to learn coding. So yeah, well, thank you all for joining. Thank you, Frank. This has been great.
No, thank you. And Rennick, Duncan, Mercy, and Hams, thank you for joining us. And let's meet here again in 2 weeks and continue this journey. Thank you.
All right. Thank you all.
Thank you.
Bye.
Bye.
Bye.